Thank you so much, Jim. Let me briefly introduce the organization. I'm representing the Fraunhofer Center for Sustainable Energy Systems and the Fraunhofer Institute for Solar Energy in Freiburg. Fraunhofer is Europe's largest applied research and development organization. It's running about 80 research institutes, the vast majority of them in Germany. But here in the United States, we have the second largest group with 6 more research centers covering areas from molecular biology, experimental software engineering to sustainable energy systems. And Fraunhofer while it is a German organization and based and headquartered in Germany, and by the way, I like to mention that, was started with funds from the Marshall Funds out from the United States after World War II. Fraunhofer is now operating in many countries of the world. Today, I want to talk about energy. And we've seen earlier a lot of examples of solar energy in particular. All these spaceships, which we saw earlier today, floating and racing through space, were powered by solar panels. If you paid attention, they were very prominently featured. And the idea is, and we truly believe, that solar photovoltaics is going to cover the vast majority of our electricity in the year 2050. So I want to show you a few examples of the progress which is being made today in making solar energy generation both high performance and affordable. What you see in the picture is probably the type of photovoltaic panel you're most familiar with, which you find on a lot of rooftops, so-called flat plate silicon photovoltaics. The efficiency of one of those solar panels is between 16 and, if you buy a really good one, 22%. 16 to 22% of the light coming from space falling onto the solar panel is converted into electricity. How about we could increase this? The technology to do that is concentrated photovoltaics. In concentrated photovoltaics, you're using, and I think I have a little laser here, you're using optical lenses to concentrate the sunlight coming from the sun. You concentrate it onto small spots. And on these small spots, you have now a very high performance solar cell. So what the concentrating optics allows you is to use only very small spots of semiconductor to convert the sunlight into electricity. And so you can now use more expensive and also much higher performance technology. So what you do then, you take these panels and you mount them on these so-called trackers. Now, one of the specific characteristics of concentrated solar photovoltaics is that you need to orient the solar panels to the sun. You have to use the direct sunlight. And so you will use that mostly in areas of the world where you have a lot of direct sunlight and less diffuse sunlight, as we would have it here in New York or in Boston, where I live. But you would use this technology in Phoenix, Arizona, in Chile, for example, South Africa, and in all of those countries which have very little cloud coverage. And these systems made out of those panels, they will track the sun 24 hours or actually more from sunrise to sunset. This is the technology which is key. You see a little chip of a solar cell, and this is a very amazing chip. This is a chip which achieved a world record performance of the conversion of solar energy to electricity of 46%. In comparison to what I mentioned earlier, 16 to 22%. 46%, this is an amazing feat, of all sunlight, of the sun spectrum falling onto this chip is being converted into electricity. And imagine what improvements in space utilization and what improvements in material utilization that can bring. However, these chips are very complex feats of engineering, and I'll show you a little bit how they look on the inside. This chip has actually 4 solar cells stacked on top of each other. There are 1, 2, 3, 4 solar cells stacked on top of each other, and it's a very complex manufacturing process. Each one of them is manufactured with modern semiconductor production methods, then on 2 different substrates, these 2 on this substrate, and then they are being taken, bonded together, and then the top substrate here is being lifted off, and then you basically have 4 solar cells on top of each other which absorb different parts of the solar spectrum. And that allows you, if carefully engineered, to capture an unprecedented amount of the sunlight and convert it into electricity. And this is a test report of an independent test lab which shows you the efficiency here of 46%, which is currently the world record. This has been a race between a number of leading research labs during the last decade. And only as far back as 6 years ago, the world record was 41%. So just in the last 6 years, this technology has increased from 41 to 46% and is approaching now the holy grail of 50%, which is obviously a goal physicists have set themselves since a long time to achieve. And so these cells, when taken into put into these modules which are showed here, the efficiency of those modules has now increased to 32 and 38% in just a short time. And that's why we think that this technology will play an important role in contributing to our energy supply in the years ahead. Now, these tend to be more industrial scale installations. You will find these power plants with these trackers more in installations from 10 to 100 or several hundred of megawatt peak because they will require some level of maintenance because of those trackers. But I like to show you, sorry, I slipped here a little bit. So they will be on these large industrial installations. And so this is now the new record, which I actually got back here talking about. It's now almost 37% as a system efficiency as compared to the individual cell efficiency. That system efficiency is a factor of 60% higher than the traditional silicon flat plate technology. So this is my comment and my remarks about high performance solar, and I'd like to show you now on the other end of the solar technology a completely different example of the work we are doing today in the United States. To install photovoltaics on a residential roof, it costs $3 to $4 per watt. Today, in Germany, taking the same technologies, the same solar panels, the same inverter hardware, costs less than $1.50 per watt. Why is that? All societies, all advanced societies, we have surrounded ourselves with a whole range of practices, how we do things, with bureaucracy and red tape. And it is a fact that here in the United States, we have made it so difficult for ourselves to do simple things like installing a solar system on a roof that it has actually become really very expensive. Our dream is to put solar technologies in the hand of everybody, and we believe that very inexpensive solar can democratize the energy system and really help to completely change the way how we think about, as consumers, about using, generating, and distributing energy. And so we are developing here in Boston in our laboratory, which I had, a system which we call a plug-and-play PV system, which is so simple to install that you could do it yourself. If you dare to go on your roof. If you don't feel comfortable to go on your roof, we recommend you call your local handyman or your brother. But the idea being, we make the system so safe and so simple to install that there are no electrical hazards encountered, not only during the operation, but also during the installation of the system. The system has electronic self-test, and it has an electronic permitting, inspection, and interconnection process, which automatically communicates with the inspection services department in your town and with the local utility to register itself, to test itself, and to obtain permission to feed power into the grid. And we have demonstrated the systems already. We have installed, end of last year, several of those systems, each of which took about 75 minutes to install completely on the roof and run through the self-testing and commissioning process so that it could feed power into the grid. So this is on the completely other end of the spectrum, and our goal is to make solar PV here in the United States on rooftops to be as inexpensive as it is today in other countries, and at $1.50 per watt. You don't need tax credits anymore. It's a no-brainer to go and install a PV system on your roof and generate your own power. With that, I thank for your attention, and I will be available for further questions later if you like to. Thank you so much.